Okay, we're in section 35. We're going to do the homework and I'll go to the whiteboard. We'll do each problem separately. Again, the intent here is not for me to do the homework for you, but you to do the homework independently. Some students do need to walk through on this though. And if you do feel like you need to walk through, just, walk through with the problems. But again, you still have to do this independently at some point. All right. Let me do a new share and I'll go to my whiteboard. And let's see what we got here. Yeah, we're right here. So I'm going to start doing one problem at a time. So as I'm reading these things over here, I'm hoping that you appreciate what you've read. And part of that is understanding it's giving you information. The first thing it says population of insects increases at a rate of. So really what they're giving me is a derivative. So I'm going to say, since we're talking about population, I'm going to say the derivative they're giving me is how the population is changing with respect to time. And what is that going to be? Well, you might also want to write down P prime of T. All right, depends what your preferences are. What's that rate going to be? Well, they tell me it's 190 plus 6T plus 0.9 T squared. And the rate of this thing is insects per day. All right. Now, what do they want me to do? They want to find the insect population after 3 days, assuming, and I'll write this one down for you, assuming that, so they want to know what P3 is. I have no idea. Assuming that P0 is 50. Well, the first thing I got to do is find out what P is. And the way we're going to do is take the antiderivative. So let's put this down. So what do you get? P, let's take a look at this, would be what? Let's see if we can do that. So it'll be 190T plus, that would be 6T squared over 2, which would be 3T squared. Oh boy, that's a nasty number, huh? 0.9 T cubed over 3. We'll simplify that later, plus some constant integration. I'm actually going to call it P naught, which is the population at time equals 0. Let's not worry about that though. So what do you get? PT equals 190T plus 3T squared. And that would be 0.3 T cubed plus some constant integration 0. So let's go back and find out, do I know anything? Yeah, I know P0 is 50. So what is this going to give us? Well, first term is 0, second term is 0, third. Oh, look at that. P naught, which is the population at time 0. So let's write this over here. PT is now equal to 190T plus 3T squared plus 0.3 T cubed plus 50. Now, what do they want to know? They want to know P3. We'll look at the key later. What do you have there? 190 times 3. That's 300, 270, 570. Again, 3, so that's going to be 927. And this is going to be 3/10. And that's going to be 27, right? Plus 50. Oh, let's see, I don't make any mistakes over here. So 570 and 27, 597. It's going to be 81/10, which is 8.1 plus 50. I think I did it right. So let's see. 647 plus 8.1. And that's going to be 655.1. You can't have 0.1 insects though, can you? So I'm going to say 655 insects. Could I have made a mistake in the arithmetic? You're not kidding. I could have made a mistake. Let's see what we got. Well, we got it. All right. Now they did write down 655.1, but you can't have 655.1 insects. So you should round your answers to the nearest insects, which would be 655. Let's go next page. I want to claim they also do it a different way. And they do it with this integration symbol. All right. And again, if you do this over here, it's really the same thing we just did. It really is the same exact thing. All right. You may want to do that. Again, final answer is 655. All right. Let's look at number 2. And number 2 is, find the displacement of the particle moving in a straight line, VT. I want to point out what VT is. VT is a derivative. It's the change in the position with respect to time. And what's that going to be? 12t minus 3. All right. Now, I need to work backwards, and there's many ways to do this. And if you did that, I'm going to say probably integration is not a bad way to do it. And then in between 2 and 5, which will give me displacement, not distance, by the way, it's going to give me displacement, 2 to 5. And what's VT? 12t minus 3 dt. Let's do the integration. What do you get over there? Let's see. That would be 12t squared over 2. So 6t squared minus 3t, limit integration 2 to 5. All right, I'll do this a different way too for the students who want to see it done differently. So let's see, 6 times 25, that's going to be 150 minus 15. That's upper limit minus, let's do the lower limit, 24 minus 6. Let's do that. 150 minus 15. That would be 135, right? Minus 20 to 18, right? Let's see what we get there. Brain's a little slow today. So let's see, 20 from that would be 115. 115, 117. I see what we got there. Wow, perfect. All right. Let me show you a different way of doing that. And let's talk about that. So VT is really S prime. And what's S prime? It's, I gotta look at it again, 12t minus 3. And you could work backwards, right? I mean, you know, if you want to get S, what would S be? Go backwards one. Would be 6t squared minus 3t plus some initial position. I'll just call it S naught. All right. So what do they want to know is, you know, what's its position at 2 and 5? I'll put this over here. S2 and S5. This is the position of the particle now. So what's S2? Let's write this down. It's going to be 6 times 4, which is 24, minus 6, that's not so bad, plus S naught. And 5 would be, let's see, 25, 150, minus 15, plus S naught. I don't know what S naught is, and it doesn't really matter to me. And what do you get over here? This would be 18 plus S naught, and this would be 135 plus S naught. Now, the displacement is just going to be S5 minus S2, and that's going to be 135 plus S naught minus 18 plus S naught. Well, the S naughts disappear, and I'm left with 135 minus 18, which is 117. Right? We get the same answer. Of course we are. Again, the way you do the problem, the way I do the problem, whether I do it 2 ways or 1 way, the answer is going to be 117 meters. All right. Okay, this is another problem. It's, you know, find displacement, helicopters with vertical velocity, VT. If we see that. So I'm going to do it by integration. I'll write this one down for you. So 1 to 9, we're doing displacement, which is easiest. It's not distance travel, just displacement. And that's going to be 0.04 t squared. I'll do the work in a moment, plus t dt. All right. I'm going to do this over here. I want to see if I can do it. And what do you get over there? Well, I'd get 0.04 t cubed over 3 plus t squared over 2, and that would be 1 to 9. Let's write this down. That would be 0.04 times 9 cubed, that's nasty, over 3 plus 9 squared, which is 81 over 2. And I will do the arithmetic, minus 0.04 times 1 cubed, well, that's just 1, over 3 plus 1/2. I'm going to do the arithmetic. And again, the way I do arithmetic, the way you do arithmetic may look different, but the outcome can't be different. All right, so it's 81 halves minus a half, which is going to be 80 halves, which is 40. And then I get this nightmare over here. So I'm looking at the nightmare and I notice that 0.04 over 3 is common to both of those nightmares. And what do you get? We get 9 cubed minus 1. And I have to do the arithmetic. You might say it's crazy. What if you make a mistake and you waste all the time doing bad arithmetic? It happens. Well, 9 cubed is going to be 81 times 3, so 243. And 243 minus 1 is 242. Now, I got to do more arithmetic. This is 1/3. This is 4 over 100 times 242. I know what you're saying. You use calculator, use calculator. We're trying to improve arithmetic, by the way. So this would be, let's see, that would be 50. That would be 2. Boy, this is a lot of work, isn't it? And 2 goes into, that's once, right? And this would be 25. So you get what? You get 40 plus, that'd be 75 over 242. You know what? I'm going to break down and use a calculator. Hope you don't mind. I'm going to just use a calculator somewhere. And let me just see if I can do that. Just give me a moment here. 242 divided by 75. Yeah, if you ever gets tired, use a calculator. Plus 40. $43. I'll write this over here. 43.23. All right. I hope I didn't make too many mistakes. I did. I think I made a mistake somewhere because it says it's 49.71. You know, all that arithmetic and I make a mistake. So what do I have to do? I got to get my eraser out. I got to do it again. But I'm going to go to Sage. You know why? Because I'm really kind of sick and tired of doing all that arithmetic. I made a mistake. And I'm going to check this out. And someone just says, you know, you just wasted time doing arithmetic. And I'm going to be honest, sometimes it is a waste of time doing arithmetic. You should use your time wisely. So I'm going to say, I think I did that okay. I mean, 0.04. Let me just blow it up a little bit, make sure I copied right. Let's see, 0.04 t cubed over 3, and then t squared over 2. And then, yeah, if this was an exam question, I'd probably say, I'll come back to it later. I said do it later, because there's no calculator, right? I'll do it later. But what I want to do now is I want to go to Sage. And I'm going to do another share with you. Let me just see if I got Sage open now. Clear it out. And let me just do a new share with you. And I want to do the problem. And we're in the homework, right? I think we're doing number 3, right? Yeah. So let me do this over here. I'm going to reset. I'm going to let t be a variable. T equals a var. I am going to integrate. What am I going to integrate? It's going to be 0. Let me get rid of this calculator here. I don't need that. Where is that? Oh, 0.04 star. Yes, you must use the star, t squared plus t. And t is the variable. And where's t starting? T is starting at 1, and it's stopping at 9. I think I did that. I'm going to get 49.71. So I had pretty good, right? Much quicker than when I was doing arithmetic, right? All right, remember on an exam that you can just pop the numbers in there. I'm going to go back to the whiteboard now. Tools are nice though. And I want to encourage their use, by the way. All right. Now, if this were me in the exam, I'd say, oh my God, it's arithmetic really killing me. I'd probably do something like this, though. I'll write it down for you. And I just hope the teacher wouldn't be too picky about the arithmetic. So that would be 4 over 300, 9 cubed, plus 9 squared over 2, minus 4 over 300, because we're doing 1 now, plus a half. And then I don't think I do the computation. It looks too difficult, but maybe I do some of it. Maybe I pull a 9 squared out. And what would you get over there? 36 over 300 plus 1/2 minus 4 over 300. And again, it's not, I realize it's nightmarish. I don't even want to bother with it. All right, it's so nightmarish. And you could do other things too, like factor a 2 out from the bottom and stuff to make it easier. But the bottom line, at the end of it, decimal number is really appropriate. All right, let's do the next one. Whoops, you know what? I wasn't sharing my screen there with you. So let me make sure I'm going to share the screen with you. Sorry about that. I just simply said that if I was an exam, I would do some work, but I'd give up in the arithmetic. I would basically communicate to the teacher computation. All right. I would say I can't finish computation, just can't finish. Computation can't finish. All right. So let's take a look at the next one. And next one, it says a projectile released from initial vertical velocity 9 meters per second. Use the formula VT for the velocity to determine the distance. Oh, this one's different. This is distance traveled. It's not displacement, it's distance traveled. So what I got to be worried about is the direction this thing's going in. And let me go through that with you. All right. So I got to be concerned now before I set the integrals up. So VT is 90 minus 9.8 T. All right. So my understanding here is that it says a projectile is released with initial vertical velocity. And if it's vertical velocity, it's going up and then it's going back down. All right. So I'm going to say, you know, our analysis here is going to start at 0. But when does the velocity become 0? At 90 over 9.8. That's when the velocity becomes 0. That's when it reaches its top position and then it starts coming back down to Earth. All right. So, you know, the bottom line is, you know, it comes back down to Earth. It's going to hit Earth eventually. And that's a concern I have. But let's take a look at that. And I'm going to go below 90 and I'm going to put a number in. That's positive velocity, right? That's a positive velocity. This is the velocity function, by the way. And this will be a negative velocity over here until it hits what? Until it hits the Earth. All right, until it hits the Earth. So let's say a projectile released from initial vertical velocity, use the formula VT, and then it says equals blah, 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 vertical velocity, distance traveled during the first 16 seconds. All right, so let me go over here and say there's 16 seconds over here. All right, let's take a look. And how would I do that? Well, if it's going up, I'll write this over here. It's going to be the integration 0 to 90 over 9.8. And that's going to be 90 minus 9.8 T dt. All right. Now, again, I want to point out to you, this says over here, it says distance traveled. So on the way down, it's the opposite of that. So I'm going to write this, it's the way down now. And that's going to be, let's see, 90 over 9.8 to 16. The opposite, it's going the other direction now. So it's going to be 9.8 T minus 90 dt. Now, granted, they're kind of nasty integrations. Whoops, there's a plus sign between those guys. I just want to look at it and make sure you can see this written over here. All right, I got that written down for you. So I'm going to say, I don't want to do the integration. I don't want to do it. Even though it's an easy integration, it's the numbers that are killing me. So I want to go to the whiteboard I'm sorry, not the whiteboard. I want to go back to Sage, and I'm going to do this in Sage now. And someone says, oh, you're cheating. Not really. I'm going to put this in Sage for you. And we're going to show you that this is the same problem. I'm going to clear, reset. T is a variable. Whoops, sorry about that. I'm not going too fast for you. T is a variable. And what I could do, I put this original integration. The absolute value is the easiest thing for me to do. And that's basically really what it is. So I'll write this over integrate. Absolute value, ABS, 90 minus, I'm going to write this as 98 divided by 10 star T. That seems strange, I realize that. And then I'm going to say T goes from 0 to 16. And what do you get? You get that number over there, which is 157028 over 245. I'm going to approximate that, dot n, and you get 640.93. Now, granted, you can also do the other integrations if you want. That's up to you. You don't have to do that. All right, let me get the next question. And I'm going to do this by integration again. And this says find the net change in velocity. That's pretty simple to do, by the way. It's just basically an integration problem. And I already got the T down there, so I'm going to keep the T. So what's the integration going to be? Integrate. Again, these are a lot of arithmetic in these problems, right? When we going to integrate that acceleration function, which is 23 star T minus 2 star T squared. T, that's my variable, and T is going to be from 4 to 5. This net change problem. And let's put the enter button and see what happens. You get 377 over 6. If you want to approximate that, dot n, and what does it give you? 62.83. So things are working out well. One thing I want to encourage you, though, you realize that, we started off that arithmetic really wasn't that bad. Eventually, arithmetic gets really tedious and boring. And I will say you should be able to do arithmetic. It gets really tedious quick. All right. So I did resort to Sage in some of the problems. Thank you for your attention. Again, if you need any assistance whatsoever, please come by during office hours, and I will be more than happy to help you, including doing arithmetic by hand. I don't mind doing arithmetic by hand, although it's like watching paint dry when you're watching someone else do arithmetic. Thank you for your attention.